All right, today we're going to be talking about the fundamental theorem of algebra. Okay, so we have seen equations that look like this right here: x cubed minus 5x squared minus 8x plus 48, in which there are repeated factors. So this equation is going to look like this right here. While there are only two different solutions, there are three separate factors when you write it out. So if we count 4 as a repeated solution, for this third degree equation. This third degree equation will have three solutions. We'll say it has -3, 4, and 4 as solutions. And then we'll see this pattern continue. And then as the German mathematician Carl Friedrich Gauss, I guess, he proved that this happens every time. And is known as the fundamental theorem of algebra. So what am I trying to say here? The power of, or your degree of your highest term right here should match always the number of solutions that you're going to have. So like for these examples here, if they're asking here and this has x to the fourth, this is going to have 4 solutions. All right, some might be real, some might be imaginary, but it's going to have 4 type of solutions. If you have an x cubed here, this is going to have 3 solutions. Okay, once again, some might be real, some might not be real, some of them might be repeated solutions. So anyways, we're going to find all solutions here of this graph. It's really not anything new that we've been doing here. We're just going to take this from the graphing calculator, find all your solutions, sketch a graph. You should have 3 of them. If you can't see some of them, then we're going to go get the rest by using quadratic formula, whatever we need to do. And we might even use some synthetic division. It's kind of like a combination of everything we've been doing. So let's go here to the graph. I'll take a pen for y. We'll clear this out. This will be x cubed, x raised to 3, and plus 7x. No, make sure you're not in your exponent anymore. Hit the over arrow to get out of that. So 7x and then squared and plus 15 x and then plus 9. And hopefully we can see some of our solutions here. So it looks like we have what's called a repeated solution right there at -3, and then you have just a regular solution on 1. Remember, repeated solution, I think we talked about this in the 8.3 video. Repeated solutions where it just touches and it turns around. So notice how that just touches. This other one, it goes actually through. So that means this is a repeated solution at -3 and then a single solution at 1. So we will plot some of those points there. -3 and 1, you have some solutions there. And the way we can write this is we can write it as x is plus 3. And then that's happening twice, so we'll put squared right there. And then the other one was x plus 1 right there. And then that's actually in factored form. Okay. And then I guess if we're going to go graph the rest of this here, we'll look at the graph. We'll hit second graph. I'm not even sure if there's going to be nice points to graph. Probably not. Actually, you got -2 and -1. So that's not actually a bad point right there. 0, 9, not going to be able to fit that. -4, -3 will actually be able to fit that. So here's a couple of points that we can graph here. So remember, touches right there at 3, and then kind of comes back up like that, and then way up here at 0, 9. There's your graph right there. We found those solutions there. If you want to write it down, I guess you can say x equals -3, x equals -3, and x equals -1 right there. And those are your 3 solutions. If you want to do kind of like what we did on the previous lesson and verify using synthetic division, we can do that. I'll just do this kind of quickly, assuming that you are good on your synthetic division and have watched the previous lessons. Bring down 1, multiply, -3, add, multiply, add, multiply. I just get 0, so the -3 worked out. Let's try out the other -3. So bring down this 1 right here, 1, negative 3, add, multiply, you get 0. That one worked. And then let's try out the negative 1 as the final solution. Drop down, you get 1, multiply, negative 1, add, you get 0. So since all those remainders were zeros, we just verified that those were all solutions right there. So depending on how they word it, you know, sometimes that's not even necessary. But that's what I did there on that one. So, okay, find all the solutions for this graph right here. Notice it's x to the fifth. Notice there's a gap. But let's see if we can figure out what makes this graph unique. So go to y equals. Clear it out here. We got x raised to the fifth minus 4, and then x raised to the third, and then x squared. Oh, whoops, I should have had a plus x squared. I did not like that there. There we go. Plus x squared, and then minus 4. And let's see what's going on here. See if we can find any of our solutions. Whoa, crazy looking graph there. So notice the power when we typed it in was to the fifth, and I see 1, 2, 3 solutions. So that's probably meaning that my other solutions might be imaginary. They might even be irrational. Since we can only see 3, which it only crosses 3 times, I think the other 2 are going to be imaginary. So we'll use this fundamental theorem of algebra. We'll chain together our synthetic division, and then we'll be able to go figure out the imaginary solutions here at the end. So that's kind of our approach here. So you can copy over some points from the table if you would like. So we got a few, really not a ton of points we can graph, but we'll copy over some of those table values here. So see, I can still kind of see it over here. It was at negative 2, 0. We're at negative 1, 0. We had, what do we got? 0, negative 4. 1, negative 6. So a little bit off the graph. And then apparently it shoots back up to 2, 0. And yep, all right, so that's that there. I'm going to relook at the graph just to kind of get the sketch. And then I'm going to copy that over. So really, when I'm sketching the graphs, I'm looking at the x-intercepts. Those are the big points there. Maybe your y-intercept's a good one if you can squeeze in a few more points. It's always lovely, but sometimes you're not going to be able to. So once again, those solutions were x equals negative 2, negative 1, and looks like positive 2 right there. All right, and then since those were your solutions, you're going to use those solutions to help you figure out the other imaginary solutions. So here's what I'm going to do. So we'll try out synthetic division here. So we'll use the negative 2 first. And then notice here there's a couple of gaps here. So it starts with x to the fifth, but then it goes to x cubed. So we're going to put a 0 for the x to the fourth term. We'll go 0, negative 4, and then 1 for x squared. Notice there's no regular x or x to the first, so put another 0 and then negative 4. And we'll do some synthetic division. So bring down that 1, multiply, negative 2, add, that'll be negative 2, multiply, positive 4, add, that'll be 0. Multiply, still 0, add, that'll be 1. Multiply, negative 2, add, negative 2, multiply, positive 4. And 0 here at the end was the remainder, so that was good. And then let's chain it together. Let's do negative 1. So drop down your 1. That'd be negative 1, or I'm sorry, positive 1 there. Already doing the multiply. Positive 1. Multiply, that's negative 1. Add negative 3. Multiply, positive 3. Add 3. Multiply, negative 3. And then add negative 2. Multiply, positive 2. And then add, you get 0. And let's use the last line right here, the last real solution that it looked like we had. Let's see if that works out here. Bring down to 1, multiply, 2, add, -1, multiply, -2, add, you get 1 again. Multiply, you get 2, add, you get 0. Now, since we did synthetic division 3 times, that means you're going to decrease this power right here, 5. You're going to decrease it 3 times. So this will be 1x, then I guess that'll be squared, and then minus 1x, and then plus 1 here at the end. Then what we're going to do is we're going to set that equal to 0, and then to find the imaginary solutions, the only other way we're going to be able to do this is using your quadratic formula, which is negative b plus minus b squared minus 4ac, all divided by 2a. So we're going to plug into that. So that'll be -1 plus or minus square root b squared, which is -1 squared, minus 4 times a times c, all divided by 2 times 1. And -1 will be +1. 1 squared is going to be 1, and then so 1 minus 4 is going to be -3. And divide it all by 2 right there, and that'll get us the imaginary root, and 3 you can't break down. So it's going to be 1 plus or minus I square root 3 over 2. Notice here, this gets us 2 imaginary solutions. And then over here, we had 3 real solutions. And the fundamental theorem of algebra was saying, check your powers. Yeah, it's not really actually spelled out for us, but check your powers. If it's x to the 5th, you better have 5 total solutions. We have 3 real, 2 imaginary. So we are good to go. And that's how you do that problem. Okay, so pretty much everything from here is pretty much repetitive after this here. So we'll do the same thing here. Take this graph, type it in. We got x to the 5th minus 2x to the 4th. And then I guess plus 8x squared. I'm going to hit second delete. You can actually just enter in one term right there. So plus 8x to the 2nd. Guess we got minus 13x. And then plus 6. And graph. Hopefully we get a couple of nice solutions here. I see 1. I see a repeated root. And that looks like it's it right there. So I see at least 3 real solutions here. I'm going to write these down here real quick. This will be x equals -2, and then x equals 1, and then x equals 1. There's another one of those repeated roots where it just touches. So you're going to write x equals 1 twice. And then you're also going to graph it here. So let me actually copy the graph over. I know we got at -2 and then a repeated root at there at 1. If I hit second graph, yeah, just like I thought, there wasn't going to be any nice points. I guess you got 0, 6 you could try and squeeze in if you want. But yeah, really just kind of sketch it, honestly. So start low, kind of go way up, come down, touch, and go back up. Big things I'm looking for, correct x-intercepts, and then if it's touching or crossing. And remember, if it repeats, it touches. Okay. All right, let's chain together some synthetic division here. So we got, let's start out with -2, I guess. And then we're going to go 1 for x to the 5th, -2. We don't have an x cubed, so put a 0. 8, -13, 6. Okay, drop down, multiply. That'd be -2, add. That'd be -4, multiply. That'd be 8, add. That will be 8, multiply, -16, add. You get 8 again, or actually -8. Multiply, that's going to get you +16, add. You're going to get 3, multiply, -6, and you get 0 right there. So I was trying to think if that was going to work out there, and it did. Okay, now we'll try out one of the repeated roots here. We'll try out 1, but we're going to do 1 twice. So 1 times 1, this will be kind of easy here. Multiply, it's going to be 1, add, -3. And then multiply, -3, add, you get 5. Multiply, you get 5. Add, you get -3. Multiply, you get -3. Add, you get 0. And then let's see what's going on here with 1 again, since it's a repeated root. So 1, multiply, you get 1. Add, you get -2. Multiply, you get -2. Add, you get 3. Multiply, you get 3. And then you have 0 left over. Okay, and then since we did synthetic division 3 times, we're going to subtract from the power 3 times, and this will be x, I guess x squared, and then minus 2x, and then plus 3. And that actually looks like it's factorable, so if we're trying to find numbers that multiply to 3 that add to -2, it's actually none that work. That's because we're probably getting these imaginary solutions again. So we'll go ahead and start plugging into the quadratic formula. It's over here on the next page, but I'll go ahead and bust that out from memory here. So that'd be -b, or -2 in this case, -2, b squared, which is -2 squared, right, minus 4 times a is 1, c is 3, divide it all by 2 times a, or 2 times 1. All right, start to simplify inside the radical. That's going to be -2 squared, that's going to be 4. Then you got 4 times 1 times 3, that's going to be -12. 4 minus 12 is going to be, I guess, -8. And then all divided by 2. Okay, break down your radical. This one actually simplifies. You got 4, 2, 2, 2. So this will be 2, I for the negative inside, and then square root of 2 left over. So this one's actually going to have a ton of 2's written, and then all over 2. Next, you reduce, but only reduce these outside numbers. And the number inside the radical does not reduce. So this would be 1 plus or minus I, or 1I, and then square root of 2. And notice that gets you 2 imaginary solutions again. And then you had these 3 real solutions right here. And that adds up to the power right there, 5 total solutions. That's a fundamental theorem of algebra. Okay. Next one right here, find all zeros of this polynomial function right here, and then I guess we can do the, find the zeros, find the factor form, all that fun jazz there. Same thing, take this, type in your graphing calculator. Clear out whatever you got. We got 2x to the 4th, x raised to 4. We got minus 3x cubed. 3x raised to 3. Then we got minus x. And then minus 6. And then let's see what's going on here with the graph. This one should have 4 solutions. And I see 2 of them. Looks like at -1 and +2. I'm going to write that down here. So that'll be nice to have. And then we're going to find the factored form here. I guess what we can do, sorry that bled over here to the next page, is we can use synthetic division to go figure out the remaining stuff here. So we'll go -1. Check for gaps. Looks like we got a few. You got 2, -3. You don't have an x squared, so 0, -1, -6. Okay, so drop down your 2. Multiply, that would be -2. Add, that would be -5. Multiply, that would be +5. Add, you get +5 again. Multiply, you get -5. Add, you get -6. Multiply, you get +6. Then you have that remainder of 0. All right, let's go ahead and use synthetic division again. Chain it together. Drop down your 2. You get 4. Add, you get -1. Multiply, you get -2. Add, you get 3. Multiply, you get -6. And you get 0. All right, and then since we only did synthetic division twice, decrease your power by 2. So that'd be 2x squared minus x plus 3. And then I guess we'll set that equal to 0 and do your quadratic formula. Oh, and as far as writing it in factor form here, I guess this is as far as you can factor that right there. So factor form, it's going to take this as a factor. We're going to write as x plus 1, x minus 2. So we'll write x plus 1, x minus 2, and then write the rest of this stuff here times 2x squared minus x plus 3 right there, just like that. And this would be your factored form for this polynomial. Okay. What are the linear and quadratic factors here? I'd say x plus 1 is linear because it doesn't have an x squared. And then x minus 2 is linear as well. And then the quadratic one that you can't factor anymore is this one right here. And then they asked us to find the zeros, so we got to find the rest of these here. So here are 2 of our zeros way up here at the top, negative 1 and 2, and then we got to find the imaginary zeros. So we'll do negative b, which is negative negative 1, plus or minus square root negative 1 squared, minus 4 times a, which is 2, times c, which is 3, all divided by 2 times a, or 2 times 2. 1 squared, or negative 1 squared is 1, and then minus 4 times 2 is 8, and then times 3 is negative 24, so 1 minus 24, this is going to be negative 23. And then all over 4, and can't break down 23, but you can put an I there. So that'd be 1 plus or minus I root 23 all over 4. And then there you go right there. So that would be 2 of your imaginary solutions. And then your 2 real are up here at the top. And those are all of your solutions there. I guess you can bring down the negative 1 and the x equals 2 down here as well. And that is it here for your lesson.